Good afternoon. Welcome to everyone who's attending. We will be starting our webinar in just a couple of minutes. All right, we'll be starting in about 2 minutes. We'd like to test out the question section. So there's a chat or a question window. While we're waiting, if some of you can just come on and tell me who you are and where you're from, we'll know that the question window is working, and we'll be starting in just a couple of minutes. Oh, I got a hello from Mr. Gordon Fellows down in Nevada. Great. Doug, welcome.
Good morning.
Perfect. All right. And where are we at? Just about there, eh? I'm just going to give it one more minute and see who comes on the line, and then we'll be ready to go. As we're going through the slideshow, if you have any questions, I'd ask you to ask your questions through the chat window or the question window, and I will, as soon as there's a break in the action, I will ask John or Dave those questions. All right. And with that, I would like to welcome all of you to the PACE Changing Minds webinar series. My name is Derek Leno, VP of Mining at PACE, and I'm your host today for the webinar series with a couple of guests that we have with us, one in the studio and one with us from Arizona, I believe.
Yeah, that's where Dave is.
Dave Richardson and John Prine. So I'll give you a quick introduction. John's well-rounded career has included a wide variety of positions in the mining industry, including safety, engineering, operations, site services, and consulting. He's currently serving as Senior Vice President for the mining business line at Stantec. John oversees a technical staff of over 700 individuals across 5 countries focused on the mining industry. With a Master of Business Administration, Bachelor of Science in Engineering, and significant leadership training, John Prine understands how to successfully and effectively manage teams of experts to ensure timely and accurate completion of projects. So I'd like to welcome you, John.
Thanks, Derek.
Nice to have you
in
our office today, in the studio. So it is. And Dave Richardson, I would like to introduce as well. Dave is an engineering manager for the mining practice area at Stantec. Dave's experienced in the development, implementation, continuous improvement of processes and standards. As an innovation leader within Stantec's global mining team, Dave provides guidance and support in identifying, evaluating, and deploying innovative approaches and technology for Stantec's mining clients. So I'd like to welcome Dave to the webinar today. Hi, Dave.
Hey, thanks for having us.
All right, good to have you both. With that, I'm going to hand it over to Dave and John, and we'll talk about innovating from the ore body out, breakthrough mining, innovating from the ore body out. So
thanks,
John,
Derek.
Here you go.
Thanks, Derek. And Dave and I want to thank you and PACE for the opportunity just to present. Thanks to the listeners that have joined in. And really, we want to take this opportunity just to talk about all the innovation that's going on in mining and how the actual design and looking at the ore body can use these innovations to change the way we mine. There's a lot of great work going on with new equipment, new processes, but actually bringing it into the mine design.
Yeah, and you and I had a few really great conversations about that as a lead up, and I think it's really exciting to see not only how technology is changing the way we mine, but how we actually have to think about designing mines.
Yeah, and I think it may even get to the reverse, where some of the ways of designing mines may change how we want to look at new equipment and what we need to do. So Dave and I will talk a little bit about that today. I'm going to do a quick introduction just on some background of where Stantec comes from. Turn it over to Dave. He's going to go through a safety share and talk really about what Stantec's Creativity and Innovation Program is that led into this work on the mining industry. It says questions and answers at the end, but like you said, if you have questions, if anyone has questions as we go through, just please type them in and we'll take them as we go along. We want this to be as interactive as it can be for a webinar.
Great.
So for those that don't know the background of Stantec, we've been in mining officially 10 years this year. In 2008, Stantec acquired Macintosh Engineering, and Macintosh came from a background of Redpath Engineering. In 2016, we acquired another firm, a large water firm called MWH. They had a group of mining practitioners. And then just this year, 2 months ago, we acquired a Canadian company called Norwest with US operations as well. We all come together to look at what we can do overall in the life cycle of mining. And really, I think we're going to talk about the life cycle of mining, really focused in on mine design and mine engineering. But as we go through it, one of the key things when you talk about innovation is, we're talking about cutters or technology, the digital, but some innovation may not be like that. If we go through this life cycle and we talk about permitting, the innovation may be how do we accelerate permitting, or how do we get mines into production quicker through an actual permitting process, or ways to understand how to do that better. Or at the very end of it, when we talk about closure and remediation, it may be the innovation may be how do we take this site and repurpose it? How do we actually transform the asset to something that's more usable? And we always look at, because Stantec does quite a bit of work with power generation as well, one of the big things now is pump storage. And how do you take this energy that's being created and put it somewhere so that the pumping later can be done to generate at the right time and actually store the energy? And when you look at a mine site that's finished, could you actually take the shaft, take the underground workings, and that would be your pump storage. So as you generate energy, the water goes underground when you need it, and then when you have an overload of energy, you pump it back to surface, and that cycle helps in the pump storage. And it's just repurposing the mine instead of just thinking of closure of it. How do you actually add more value on it? But for this, we're really going to focus in on the mine design process. And before we start, as always, we talk with safety, and I'll turn it over to Dave.
Thanks, John. Yeah, pardon me if I cut out. I just had the pleasure of dropping out for a few seconds. As John said, we do weave within our work program we call Prevention Through Design. It's a focus on designing out many of the risks that workers in a mine will face by focusing on a hierarchy of controls. So this hierarchy of controls is based on a tiered system of identification and mitigation of risks, starting with risk awareness across your team. You seek out to identify risks in the construction, operations, maintenance, and even closure of mining projects. Beginning at the top, definitely the most impactful way to mitigate risk is with elimination of the hazard at the outset. If you can't eliminate, you look to substitute and replace the hazard with a less impactful one. Moving into redesign and separation, you're now relying on the engineer or the constructor to identify ways of making modifications during construction, possibly during management of change in operations. And lastly, you're at the bottom of the hierarchy now into administration and personal protective equipment. The reason we think of these last, they're the most reliant on human decision making and discipline, and as a result, they're less effective. So applying hierarchy of controls to something that's maybe relevant to our conversation here today, certainly one of the hot topics in innovation within mining, does focus on some specific technology, in particular automation of mobile machinery. Just trying to get my slides settled here. Sorry about this. So what does this mean to us in a practical way? Well, the top 3 sources of fatalities in 2017 for underground mining, as reported by MSHA, were related to powered haulage, machinery, and fall of ground. These are critical risks that have a high impact, usually leading to all the time, but when they do, it's sometimes catastrophic. Certainly using the hierarchy of controls does provide an argument to using automation to help mitigate those risks. Elimination, kind of the holy grail that people are chasing with automation, is the potential to remove all personnel from the mine. Now that requires automating the full process, including maintenance, which is very difficult to do, but certainly working towards elimination is the pursuit of zero harm. Substitution, you're looking at maybe in the picture here, using teleremote technology to if not completely remove personnel from the hazard, it's to at least substitute it for a lesser hazard. Maybe it's a secondary contact with machinery that might occur in this case. Moving through the list, redesign, separation, administration, PPE. There are kind of lower hanging fruit available to you to mitigate some of the hazards of personnel contact with machinery, fall of ground, all those things, by leveraging some of these innovative technologies to allow operators to do their job from a more safe working environment. And as we say, it may not be the only solution, but we think it definitely has to be part of your strategy for pursuing zero harm. Back over to you, John.
Great, thanks, Dave. And I like that picture, Derek, that he showed, because it gets back to probably 15, 20 years ago, where people were going into large stopes with LHDs and said, this is safe. This isn't safe. How do we remove them? And that's where this teleremote came in. Yeah. Then you take it to actually removing them from underground, where they're operating at via video camera and television monitors. And the future will be where it's operating itself and working itself through the drift. And it allows us to talk through and see what the sequence looks like. And it adds into what we're talking about today with design and looking how the mining design and methods can actually be changed to apply the technology. And like I said, eventually driving some of the technological changes. Yeah. So I'm going to talk really about an innovation program. And this is Stantec's, we call it creativity and innovation, but it's very similar to what's going on in the industry. And our Greenlight program has 2 phases. One is R&D, and for many years, research and development. All the major organizations had research and development arms, and as we know, the mining goes through its cycles, and those groups really suffer with the cyclical nature of the business. And that's part of the past history of why innovation took so long and was difficult to get involved in the mines. But that's changing now, and R&D changes are happening more frequently. But the other part to this Greenlight is new ideas and very low cost, quick analysis, getting back solutions quickly. And part of that is realizing that when you get these ideas, you're going to invest so little that you're going to know 90% of these are going to fail and only 10% will be the success, but it'll still pay for the program. Yeah. Where with R&D, it was so heavily burdened, so time consuming, that if that project didn't succeed, you were really at risk. And then people got tied and glued to those projects, and sometimes took us down a wrong stream and delayed the industry. And that's why we think, this new idea of failing fast that's out there in the world, we really need to figure out how we apply that to the mining industry. We'll talk a little bit about that today. That concept is realizing that you need to try a lot of things. They won't all work, but if they don't stick with them, work them through, and continue to be embraced to them. Realize that they maybe fail and move on to the next ones quickly. The next one is publish and speak. And the mining industry has been doing this for so long. This is part of Stantec, where we promote people going out to conferences, to lectures, or holding their own workshops. And that's one of the best things I've seen in the mining industry now, is how the innovation talks and the sharing of innovation that each of the companies are doing really helps to give a better understanding for the industry as a whole. And that's what our third one is, Breckenridge. It talks about projects we've executed that had innovation in them. And that sharing is what the industry is doing now. People aren't there's still the IP of keeping information, but the general share within the industry to make sure we're all getting out, we're all getting ahead, we're learning from one another. That's one of the great things about the mining industry. It really looks for what's best for the industry and how do we promote it. And this is just the same type of thing. And then the last one for Stantec is a venture fund where you're putting in a lot more money to help bring that actual idea to fruition. So it's really a process of stage gating, almost similar to what the industry has in place. So we'll be talking about different examples of these. The majority of this comes from what we called our idea stream. With that, I'll turn it back to you, Dave, just to talk a little bit more about our breakthrough by design mining.
Sounds good. So yeah, our concept of innovating from the ore body out is maybe a little bit different than what's going on out there in the industry. We find that innovation often finds its way to focusing on specific technologies, specific portions of the mining cycle. And our approach is to really think about the overall mine design. We have a lot of good benchmarking and knowledge about what mining today looks like. A lot of that does involve linear gains in terms of improvement, slightly fewer materials, maybe slightly steeper declines, maybe some successful automation of a portion of your project, those sorts of things. Linear gains are great, but certainly there's a diminishing return on investment that we need to break through. And what we hope to talk about today are some methods by which you can change that mindset and break through to mining tomorrow. Certainly a lot of this has to start with why. This is a story that's well told, right? We have mines in more remote areas, lower grades, environmental concerns that are getting harder and harder to satisfy as far as community stakeholders go. Total cost of ownership does seem to be on the rise, certainly from a CapEx perspective. Inflation is not going away. Complexity of these projects for sure adds a lot of areas of risk that make people uneasy, and often that draws out the time frame to get approval for a project. So what we're attempting to do here is to challenge that status quo. That paradigm shift that we're looking for is based on full removal of personnel from the hazard. Like the pursuit of zero harm, it may not be fully achievable, but in doing so, you allow for, it's not about fewer jobs, it's about more mines, potentially different jobs in more locations where otherwise mines would not exist. So we have to try and attack that item where people get their backs up when you talk about removing personnel from the mines. Not removing all the miners, we're just repurposing their skill sets and putting them to work at more locations. Certainly the how we do that is important to talk about. Conventional mines, conventional approaches, fairly well understood, notwithstanding some of those difficult conditions. They're easier to understand because we've got a wealth of knowledge, a lot of benchmarks available to us, a lot of familiarity. The challenge with breaking through and getting to that mine of tomorrow is how you conduct those evaluations. First, identify those applications you can apply, evaluate them, and approach it with that fast fail mentality. Identify where you've got a winner, where you've got a loser, and try and do so off the critical path. So we want to talk about changing that mindset, which can lead all the different stakeholders, from consultants, from mine owners, OEMs, even governments, to failing fast, but also succeeding fast in applying some of these approaches to break that paradigm. So in doing so, we, false start on the slide change. What we want to really convey to you is that there are amplified repeat gains available in this thought process. Again, it's human nature to just hone in on a specific problem and try and provide specific solutions, but a step back is really required to understand the overall system, understand the overall impact of the decisions that you're making, and really to identify those opportunities to.
I think we lost you there for a second, Dave. Hopefully he jumps back in here in a second. John?
Yeah, so I'll just keep going while
pick up a
Dave,
little bit of that?
yeah, until Dave gets back in. And, like he was saying, they each have a ripple.
Oh
There you
yeah,
go.
sorry, my
Dave, we
audio's
lost
cut
a
back.
bit there. Yeah, you're back now. That's great.
Right on. Yeah, has a ripple effect, as John said. If you're able to simultaneously apply some ore and waste sorting at the face, you're now transporting less material to surface. That might enable you to leverage alternative haulage methods, which will drive down your drift size. Again, that'll have a spin-off of reducing your waste stockpile on surface, and so on. So it's really about understanding how these solutions flow through in an integrated way to all aspects of your mine design, and not just focusing on improving the specifications of one item in the cycle. So again, the focus is reducing that time to first ore, reducing total cost of ownership, and of course, reducing that footprint. That allows you to approach other jurisdictions and in mine and sensitive areas because you're committing to reducing your impact. Of course, in doing all this, you're going to see an increase in safety. You will see an increase in productivity, and your cutoff grades may very well improve as a result. So in a bit of a high-level perspective, this is kind of how we see what the mine of the future could look like. It's definitely something that means something different to everybody on this call and throughout our industry. But in the simplest form, it's how do we find ways to either reduce or eliminate parts of the conventional cycle and completely overhaul the approach. In this case, it amounts to pulverizing the ore underground and extracting it through a single heading by call it a vacuum, if you will. It's really trying to simplify the process and focus on productivity while ensuring safety.
That's good. Run that one more time. I like that. So the premise here is you can get to the ore body and actually extract the ore in a different way than we do today.
Correct. And hey, we don't have the technology necessarily available to do this, but this is about charting that path to the future and enlisting help from partners across the industry to achieve it.
Right. That's interesting as well in the previous slide that you showed how some of these things are all linked to each other, and by doing one, it can facilitate the ability to do all sorts of other changes that may come into place.
And we'll give more examples on it. It's actually thinking about what is, the ripple effect or the unintended consequences that actually even help make the process even better than you thought it was with the implementation of this technology.
Yeah.
Right.
So I think I'll take over here. Oh, sorry, Dave.
Yeah, no, I was just going to hand off to you.
I'll take it over here and I'll just give one more specific case study. Just a really simple example of, driving a decline to access an ore body. We use some standard design techniques, about 500 meters underground is your ore body. We're going to use a 12.5% ramp, and standard design is 15%, but you level off for safety factors at different levels. And because it's so long, you have to run a twin decline. And when you do all that in a drift that's 5 by 5, you'll see that it actually comes up to be around 630 kilotons that you're storing on surface.
Right.
And it's going to take you a little over 3 years to get there. So what we talk about in the technology is, how do you change the equipment you're using, the ventilation you require, or whatever, what other elements. And let's say we go to a 4 by 4 drift. So we're doing the exact same amount of development. We just changed our profile of the drifts. We can do that because new equipment's out there, or because the ventilation requirement with electrification has gone down. Mm-hmm. So you don't need as much room for your ventilation pipes. Exact same design parameters except the cross section. And you've now reduced your stockpile by 43%, and that impact on surface and the ability, like I said before, in permitting now is improved because you're doing less impact of what the actual surface interference will be. But let's say besides that, we want to make even another change in technology, because we're going to use conveyor or other type of minecart technologies and not going to run trucks up the ramp all the time to get rid of this material. we can steepen our ramps, and we'll go to a 19% grade. And as we get the technology that allows us to do this, we've further reduced 62%, and you can sort of see the ghosted stockpile that we started off with to the solid one, and how we've reduced that footprint. And again, it all has a ripple effect. With the schedule now, we've gone from a little over 3 years to a little over 2 years. We've reduced the time, we've reduced the cost, we've reduced the material on surface. And the other impacts is, we've reduced the bolts, the screen, the shotcrete, all the associated infrastructure that had to go into it. And the positive benefits of that, whether it's material transport, material storage, or just the demand for materials in general, is all seen as a benefit to that. And that's just looking at the ramp and the twin declines. And then you get into thinking, well, what if the twin declines are so short now that you only need one decline and you can put some small raises for ventilation because you're not running that much diesel equipment, and you cut this further in half. Or you say, instead of conveying or carting the material out, as Dave showed sort of in the previous visual, we get some type of hydro hoisting where the material is not being transported up in a hard form, but being broken down and put up in a slurry and being and pumped to surface. And I think that's really what we're talking about. And this is just one example, but it goes into the ore body as well, Derek, is we're talking about how do you mine that differently. And that's part of when we talk about cutter technology. It's not just there to replace a jumbo and a loading machine, because if that's the limit of what we think we're going to get from a cutting technology and more efficient because it runs 24 hours and not a batch process, we're not truly looking at the mine design and how we can take advantage of that. So how can we, with the cutter, drive it steeper, or because the material now is so small and fragmented, transport in a different means? Or, getting back to what I showed in the life cycle, if we look at the innovation for processing, back when I was previously with LA in my current previous role, we talked about a great project they did at their Clarabelle mill to improve copper recovery. And that was the innovation of the time, was better copper recovery by 2%. But imagine if you could actually take your material processing further downstream and you're leaving 25, 30% of the material that's waste underground right where you're mining it and putting it right back underground instead of bringing it all the way to the surface, having to put it in a mill and potentially in a tailings storage. So that's really what we are really focused on, is taking the technology that's out there and looking at how we mine things differently, or how we use that and the outputs of that, like a smaller particle size. How do we use that to actually change what we're doing? So it's not just replacing a jumbo and a loading machine. We're actually looking at the entire processing system and saying, how do we move it closer to the ore body and redesign from the ore body, right? That's right. Yeah, no. And Dave talked about the need for it. The industry has mined a lot of the good ore on surface, a lot of the ore that was at lower depths. Now we're going deeper. We need higher grades to sustain them. So it is a more difficult business case to make, and all the companies know that, and they're looking towards innovation to do that. And it's not just the resource of the material in the ground, but the resource of the people that run, that operate, that designs these mines. It's a changing culture we have out there too, Derek. And as the mines get more innovative, more state-of-the-art, looking at how we reduce footprints, economically friendly, environmentally friendly, the footprint at the end of the day, how it actually improves, that itself is going to bring more resources to look towards mining and look at it as actually not an archaic method, but actually something that's innovative. And that's one of the risks we're going to have, is actually the resourcing for the mines as we get back into these upcycles, especially, with the new generation of workers that we have.
For sure. That's great. I love that you're looking at not just the cost, and you sort of hit at the cost, but the time, to get to that ore body. The environmental impact is a big one, and I think that's something that people really need to think about more and more, is that environmental impact, and how can we take a lot less rock out of the ground when we're mining. And I was fascinated at a conference recently. I was listening to Michelle Ash from Barrick Gold talking about just the sheer amount of rock that you need to pull out of the ground to get 1 ounce of gold. And it was staggering, the numbers she was talking about. And, you know, you don't really think about that. I don't certainly think about that. I mean, mine engineers obviously do, but you know, it's amazing when you start thinking about, you know, can we pull less ore out of the ground, or less rock out of the ground, to get at that ore. And I think that's really starting to think differently about how we approach mining and how we approach an ore body.
No, you're exactly right. I mean, unless you've got a zinc or a chromite deposit, 90% of the material you bring to surface is waste.
Right.
I mean, and that's at a best case scenario. Yes, Michelle Ash's example for gold is, you know, 99.5% of that is all waste. And how do you actually reduce the waste in your system? If anybody's had lean manufacturing or Six Sigma, you know, anything you're moving which is waste is no benefit. And, you know, funny, funny you mentioned cost, because Dave and I were talking in the presentation about putting a slide in here in cost, and you know, we said there's too many engineers. We don't want to get in an argument whether it's $2,000 a meter or $4,000 a meter, but you can't argue a cross section and a volume. And really, that's the gist of it. The time and the volume of rock and the volume of materials to support it really reduces dramatically, and associated with that will be the cost that help makes these mines more profitable and more feasible.
Yeah, that's great.
And so just a few examples, we talked about some, but how do you actually make this work? And for that, I'll turn it back to Dave just to discuss it a little further.
Yeah, so it's certainly a different mindset required. And as John mentioned, that's not just innovation in isolation. That's getting a team dedicated to the cause, okay with quick failure, shall we say, or fast failure. It does take, hello? Sorry. Okay. Yeah, it does take some keys to success that we've identified as a combination of commitment, cautious optimism, and collaboration. The commitment is all about having that vision, understanding what the mine of tomorrow looks like to you and your partners, and adopting that mindset early. We will also be talking through some of the cautious optimism. Certainly, it's great to be optimistic about achieving that full build out, that mine of the future, but you need to do so in a staged approach. You don't want to fail across the board and then become gun shy as far as pursuing the next innovative technology. So it does take some patience, balanced with some stubbornness, shall we say. And then lastly, collaboration. We will get into talking about the fact that you can't really innovate in isolation. You need to work with the rest of the stakeholders in the industry and try and achieve success together. And combined with the staged approach, how can you do that off the critical path where you get burned once and you're more hesitant to pursue innovation again? So we'll walk through these three keys, and certainly as you're listening, if you've got keys to success that you find very valuable, please do provide that feedback to us.
Yeah, and just a reminder to everyone.
So starting with,
sorry, Dave, just
go ahead.
to give a reminder out there, if anyone has any questions as we go, feel free to type them into the question window, and I'll make sure to ask them when we get a break in the action here. Sorry, Dave, back to you.
Good. No problem. So yeah, one of the first keys is that commitment. It's starting with that life of mine vision. Dial it back to that cartoon that we illustrated. It may be a bit of an audacious goal, but really, if you don't chart that path for what you want your mine to look like in the future, you'll be hard pressed to break through. Of course, you have to admit to the fact that a lot of us are nitpicky engineers, and you will need to do some research, but also that open-ended artistic brainstorming. Really try and identify all the alternatives out there, whether they're mature or emerging technologies. And lastly, laying out that execution plan. All of this packages up to commitment, because it really means defining and committing to that vision early in the process and sticking to it. Putting all those ingredients together, ideally you want to build a technology and infrastructure roadmap for your project that lays out a clear vision and steps to get there. in a way that all the stakeholders understand. We're going to take a walk through some of these snapshots of technology and innovation roadmaps. And you have to accept the fact that not every group or partnership is willing or able to go, quote unquote, all the way. We need to understand that different minds have different appetites for innovation. Different business cases will dictate the level of success that you have in going all the way with some of these innovations. We'll start with development and production. Certainly one of the creativity and innovation projects we've been working on internally here has been trying to identify what some of these alternatives are, whether they're wild or mature ideas. Our pathway to breakthrough takes current batch mining, applying continuous mechanized mining in hard rock applications, knowing that soft rock is certainly pursuing a lot of this already, and arriving at, as the cartoon had indicated, in situ mining for hard rock, whether that's liquefied applications like a slurry through hydro hoisting, or it's something a little crazier like busting up the rock in place and sucking it up with a vacuum. You need a pathway to what that minimal impact, high productivity, high safety mine will look like. Another pathway, very much a buzz topic in the industry, is machine autonomy. Again, we think machine autonomy is very important to helping achieve success, but it is one leg of the journey. Within that journey, we've got local or manual operation, maybe extending that to include teleremote or line of sight operation. And that's not just in production, but looking at applications for development and blasting as well, for example. Continuing along this pathway, of course, remote control from surface is definitely something that there are success stories out there in limited applications. But really the giant leap from there is not only remote control from surface for production, but also the concept of machine self-maintenance, machines reporting to maintenance bays by themselves, perhaps being serviced by robots in the maintenance bay, controlled from surface, for example. It's really identifying what 100% autonomy looks like for a given mine. And again, we're not suggesting that you just race out to the end in all these fronts, but you work with your partners to understand what your roadmap looks like for your specific application. Kind of grouping a few things together in terms of mining efficiency. We talked about continuous mining, for example. We talked about, in John's example, leaving some of that waste underground or really just extracting less of it. And right now, a lot of cases we're going through that ore and waste sorting process on surface. So you're spending a lot of energy to get what is eventually waste to surface, where it's then discarded or otherwise returned underground. Moving through an evolution, there are definitely some success stories out there today involving ore and waste sorting at the face. This allows you to keep more material underground where you will otherwise need to use it again in your cycle. If you combine that with some of these alternative material handling technologies, like independent cart technology, for example, where you can be selective of where your ore goes versus where your waste goes, and you combine that now with in situ continuous selective mining, you're really being very precise, a little bit more surgical in how you extract your ore and direct that specific pile of ore to a specific location while keeping your waste underground for reuse for backfill, for example. And of course, digital transformation is tied to all this. Yes, it's machine autonomy, but it's also enabling the leveraging of big data. And again, I'm very much in support of pursuing deploying advanced digital technologies, automation backbones, and all that. But it is a tool, and it's a tool that the purpose of which is to really improve how mining is done. Digital transformation consists of now what's generally accepted to be conventional, local PLC and HMI control. There's definitely a movement towards integrating process and business networks on surface, getting IT departments involved in the day-to-day operations of mining, and extending to include remote operation centers off-site. This is setting up an office complex like BHP and Rio Tinto have done in Australia, maybe attracting the millennials who maybe prefer different working environments than their parents did, and doing this in a big metro area where you're able to receive all the data you need to make real-time decisions, knowing that it's a high volume of data required to do that. So those are just some of the pathways that should be part of your technology roadmap, but definitely implementing them is an issue to be dealt with on its own. And with that, I'll hand it back to John here to talk about implementation strategies.
Thanks, Dave. And I mean, one of the things I wanted to touch on is that whether it's prototyping or innovation, you still need to look at the ore body. You still need to see what the resource looks like, because there might be some variation in there. And, you know, it may still be a block cave mine because it's so massive and low grade, and the innovation there will be figuring out how you reduce the water going into that and how you move the material as quickly and as continuously as you can. Or at the other extreme, it may be a narrow vein deposit where you're figuring out, yeah, how do we take this as narrow as we can? We, as Dave said before, take the waste, we sort it, we leave it underground, and we only bring that very high grade material to surface, and we've reduced the amount of material coming to surface and really put a high grade product through the mill, which will increase recoveries as well. So it's not a one size fits all, but the concept of the innovation using the different technologies to match the ore body is really the message that I want to make sure we pass along. So how do you do that? Well, if there's a new way you want to work on things, one alternative is just take that new way, put it in right away, and do it on the critical path. And I mean, this is one of the things that really, it drives technology, it drives innovation, but there's lots of risk in it. If that technology, that approach doesn't work, especially in mining, large investments, large time has been put into it, and how do you recover, and how do you keep the shareholders convinced that the money that you've spent that's not working now is a concern. So the new approach, if it works out, is a great result, but some of the resistance just has been because we're so capital and time intensive, how can we make sure we justify that? Yeah. You know, so another alternative is the dual path. Put in the conventional approach, a way of doing things, make sure that's there, ready to go, and in parallel, try to put in some new technologies, try to innovate us to the next step. This is really a risk minimization step. It allows you to, if things fail, we still have the conventional way to do it, but if it's there, we can implement and use its technology to bring us to the next step. This has an added cost to it, but it also has, you know, minimizes the real drive to make sure the technology works. And unfortunately, we were talking about this a little bit before, Derek, when you have the pressures of production and making sure you're meeting the shareholders' need in the day-to-day, in parallel trying to implement this technology, or, you know, as things with the technology start to show a little bit of concerns that you need to work on, it's quite often the default, okay, let's just go back to what works because we can justify that to the shareholders. And we need to get out of that concept. You know, so one of the ways to do that is the new approach ahead of time. How do we figure out what this is going to be, do some testing on it in a prototyped area, and then bringing into operations quickly and getting that worked on. And Dave mentioned mine carts, and there's lots of different examples. It's funny, we talk about new technology and people say mine carts, you're thinking you're talking about rail and muckers, but really that is a great step as we're talking about getting to a continuous system. If you've got carts that you can load continuously, whether it's in a string or single, and you can redirect to ore, to waste, to different locations, that can have a great impact on it. And, you know, so we take some companies out there that are doing that now, and the biggest risk I have, a concern I say, is you don't want to take that technology and just say we'll compete against, you know, the conveyor or rail haulage. What you've now done is you've created a technology that allows you to mine and do stuff differently. And especially if you add on to that the cutter technology, so that all the material coming out is small size pieces, you can load those into those carts. And now you can do that anywhere. Instead of having an ore pass, going back again to previous technologies, taking an ore pass, it falls by gravity, and then you put it into a larger system, or that's where the trucks get it. And really what you're doing in that process, getting back to lean manufacturing, is you're adding waste. It's a longer distance to haul or a rehandling process. How do you use this cart technology to load at every level where that ore is and then bring it to its exact location, whether it be waste or ore, in that next step? So you're not having to a stockpile, to an ore pass, to a crusher, to a storage bin. It's from the mining ore body, whether it's a face or a stope, into these carts to surface of its ore or to a waste and dump location as final destination of its waste rock. That's really some of the approaches we're talking about.
Yeah.
So, I get back to the term fail fast. And again, just to reference that, that's having enough ideas out there that we realize in the industry, some of them won't be successful. If we're living in an industry where we think innovation is going to be 100% successful in all the ideas, we're going to be in a struggle to start off with. So how do we get a lot of ideas, work through them quickly, and then put them into implementation, those that have been successful, and maybe 10 or only 20% that reach that. I think back again to the cart technologies. We can't take 10 or 12 years to say the cart technology works. We've got to say in a year it works, and then in a year later say, here's how we can change mining to use it, and here a year after that is how it's institutionalized and utilized. And that's 3 years, which in a lot of the other industries is a very long time to have stuff going. But for mining, that's part of where we're at. But that type of technology, unfortunately, sometimes takes 5 years just to get people's confidence, and then looking for one person to do a trial of it 3 years later, and you're 8 or 9 years down the road, and people are saying, yeah, maybe it will work. And we've got to try to change that mindset. And this new approach to prototype, get it tested quickly, put it in a test facility. And one of the great things is sharing that knowledge, the openness. And I know even some of the mines that have this technology in there are allowing, the manufacturer to bring people in on a regular basis to see how the technology works. And it's that type of partnership that's really, really important. And it leads sort of into my next slide. So what do we do as we do this? It's really establishing a cross-functional team. Obviously you need the owners, the operators, the people that are mining the ore. You need the equipment suppliers, you need engineers, but there may be other ones you don't think of. And it's interesting as you look at, some of the things in the industry. A lot of the procurement groups look at Amazon, for waste material. Who would have thought a mining group is going to look at how Amazon delivers material? But you can't argue with the success they have, right? So exactly. That cross-functional team may be nobody you would have thought of 5 years ago on a mining cross-functional team, but it's that out-of-the-box thinking we need. Yeah. Then brainstorming. What is the problem we're actually trying to solve? Does it take too long? Is it too long in inventory? Are we moving too much waste to surface? What's the problem we're trying to solve? And with that group say, here's the solution. And, I want to give credit to everybody out there, because the suppliers of equipment, the OEMs, it's a large financial burden to take on some of these trials. And they've partnered with the mining companies. They've taken a lot of the brunt on themselves, but they're committed to making sure that we're changing the industry, and they need to be recognized for that efforts, and it's much appreciated. This is the next step about how you actually take that technology, that equipment, and further utilize it down the, back further into the chain to improve stuff. So they've done it. They've done a quick testing at a prototype. And it's funny, I like to talk about prototypes and I'm big on cutting technology. I think that's going to be a way of the future, definitely in the midterm. But if you look at 10 years ago, rock's just too hard. Canadian Shield, you can't cut the rock in the Canadian Shield's too hard. But if you were to graph how cutters are working, the strength of the rock they can cut now, it's almost exponentially how much it's improving. And we're going to see more as time goes on. And I think 2 years from now, the hardness of the rock won't be the issue. It's now talking about what's the smallest piece of equipment we can use to cut this rock. So you test it, you prototype it, and then really you put it into action and test it. But when you do these tests, it needs to be the mindset that it's going to go in 80% ready to go, and we're going to fine tune it. If you're waiting for it to be 100% perfect, you'll never get it in your mind. Or if you put it in at 80% and you have struggles and you throw it away right away, you're not going to get there. So knowing things are going to go in, you're going to continuously improve it, you get it to the next steps, and everybody will learn from that. And I think that's part of the thing as we go through the path to breakthrough. It's on, working from the ore body out, looking at what the OEMs are producing and figure out how you utilize it different. But the big thing is this sort of flow chart about getting the right people in the room, looking at the problems we need to solve today, but also the problems of the future, and what is the solutions that are going to get us there. Yeah. And just talking about the solutions that are get us there and some of the opportunities. I just want to turn it back to Dave now to sort of do a few slides before we wrap up. Great.
Yeah, thanks, John. So yeah, as John mentioned, that process requires a cross-functional group committed to the same goal. That group includes the range of stakeholders out there. That's owners, consultants, suppliers and contractors, but also governments, communities, and so on. It's realizing that it is a heavy burden for any one of these stakeholders to try and carry. Certainly, there's a mix of skills and capabilities that each group brings to the table. Governments are interested in economic development, but not at any cost to the environment and their stability. Suppliers and contractors, like John said, are innovating all the time, but it's a disproportional risk if they can't find a buyer for what they're trying to make, and maybe it just results in linear gains if they're doing that in isolation. Mine owners traditionally need to be making that big push, but they may not have all of the in-house expertise required, and that's, I think, the approach that not only us as consultants bring to the table, but even suppliers, contractors, and other industries, is having that variation in mindset and approach. You really get some wide-ranging ideas to the table if you have a good mix of people at that table. And so certainly it's finding ways to partner up across these stakeholder groups and find some success. And that's just it. We're not just here to talk about mining as a laggard industry. There have been a tremendous amount of improvements and innovations in the industry. We do need to do more to promote each other's success stories in that space, and you are seeing it. A lot more collaboration across the various stakeholders, mine owners working with other mine owners to find some of these solutions. Certainly, some of the success stories that have caught our attention lately. In a sense, it's innovation that's been happening for some time already in terms of potash. They already do in situ mining in a number of cases, and continuous mining. And really, we think of that as a dirt farming underground type of industry, but there's a lot of things they've done maybe under the radar that really we're just looking to apply some of those techniques to hard rock mining. So a lot to be learned from what the potash mines are doing and other soft rock mines. CMOC North Park's mine, I believe formerly Rio Tinto operation. Back in 2015, they had success with autonomous haulage in their block cave operation. And of course, with Barrick Cortez, they're having some very specific successes on tunnel boring machine roadheader applications in Nevada. And certainly the industry is watching all these success stories with optimistic curiosity, and certainly wanting to know how these sorts of success stories can be applied to their project as well. There are other success stories out there. Obviously, everybody on the call likely has one or two worth mentioning, and really to our point, we want that sharing to happen. It's important for us all to understand that some of this stuff isn't so futuristic. It really just takes that mindset and commitment to tackling these items. For our part, John had given a good rundown through our creativity and innovation program. This is our way as consultants without as much skin in the game, so to speak, as the rest of the stakeholders. We have to try and contribute to failing fast, coming up with those new rules of thumb, those at least theoretical benchmarks to help our partners identify opportunities to flip the paradigm and approach mine design differently. Some of that is aided with augmented reality simulation, but also brainstorming and identification of some of these alternative approaches or technologies. And in some cases, doing research and development on some of the specific technology applications as well. So it's a program we take pride in. There are, however, certainly a lot of comparable programs out there in the industry, and really the biggest bang for our buck as an industry is finding ways to link up each other's programs together, spread that risk around, and commit to failing fast as a team and finding those success stories.
Yeah, I mean, I think we'll just conclude. I see a few questions on the screen, which is great.
Yeah.
We'll get across to them, but I'd like this photograph to end. It's not the most innovative one, but it gives you the thinking of what can be different. You look at the size of the drift, you look at the amount of shotcrete, the ventilation that's going through there, and the equipment that's sized for that. How do we actually going to change that? What will it look like in the future? And how do we get the ore recovered fully or as close to 100% recovery, and yet still leaving waste underground? And like I said, the industry as a whole has made tremendous strides in innovation. And I think really the drive now is how do we continue to implement the innovation changes we're doing and continue on that road path, but using it, and Dave said, more in a collaborative model to say, well, maybe mine design and some engineers can say, here's what we need from the OEMs, or OEMs can say, if you guys could design it differently, this equipment would do that. And it's that collaboration, because we just don't want to take a road header or a cutter and replace this piece of equipment, and that's the only change we make. If we've done that, we've done a failing to the industry, and we're not going to get maximized out the resources we need. So working together to make that happen. And love to turn it over to some questions now, Derek, if that's all right.
Yeah, no, absolutely. That's great. I appreciate it. So we do have a couple questions coming in, and I've got lots. But I'll take your questions first. So anyone who's got questions, please feel free to type them into the question box. I've got one right now from Deanna, and I'll read this. It's a bit of a longer question. In the case of slurrying material, how much added time and cost do you think will be added on average to the beginning of the project exploration to better define faults, water tablets, low-grade areas? Also, how can you explain low-grade areas that were not picked up in exploration holes to stakeholders who do not trust the process? Do you think there will be a lot of pushback saying that the new method is not mining that ore correctly?
Yeah, and maybe I'll start. It's a great question, Deanna. And I mean, we need to really think about what it looks like in the future. And if we didn't have to put a shaft down there and access it, which would take 8 or 9 years, and the multi-million, how many actual more drill holes? If we knew that was the actual end process, how many more drill holes could we put to just really, I'll call it, pepper that ore body to get a better understanding? Because that upfront cost. Next step isn't a huge capital underlay to get that done. Those holes, maybe the sunk capital cost that you're setting up to extract the material with, or a lower cost. So I think you need to look at what the total cost of the program will be. But definitely, to your point, it gets back to what we're saying. You need to understand the ore body. You need to know how it's going to fit and what's going to work. And that's just steps you would take along the way to make that happen. And it's one of the things as we go through this technology that we're always talking, with my team on, is as we go through, there's always going to be roadblocks. Our job is not to figure out just about what the roadblocks are, but how we get around them, or how you do something that doesn't even put the roadblock in your way. Right. So that's a great question. And I think that might be one of the solutions, is you're putting more holes in and it's still a lower cost project overall.
That's great. It's trying to make sure we don't get hung up on the barriers, identifying them. Definitely the question in itself identified a few of the very specific challenges we need to overcome. But back to that optimism part, we're confident that the ingenuity of the industry, given these identified barriers, will find a way to resolve them off the critical path if we can get those partnerships going. The technology will be developed to solve the problem. The barriers will be worked through collaboratively by maybe evaluating some of these fast fail items ahead of time, understanding the full impact. We have a hesitation to get hung up on the specific issues, but if you're comparing it to the 8 or 9 years and $1 billion to sink a shaft, really gives you pause. What else could you be doing with that money and time if only you could apply a different approach?
Yeah, that's great. I just wanted to talk, you guys you talked a lot today about collaboration between mining companies and vendors, between vendors. of similar technology, of similar products. Do you see that happening more? I know I'm starting to see a lot more with groups like GMG and CMIC driving some of that. And what are you seeing today that's encouraging?
Yeah, I mean, I think the industry as a whole, like you say, setting up these innovation networks that aren't one mining company setting up their own R&D or innovation group. It's a collaboration of those companies and a collaboration of the OEMs being part of that as well. So I definitely see that as a start. I think, I see more about government coming in and helping to foster the work with the OEMs and not just have the mining companies support it. And I think the biggest one is open doors and open communications. I know you've had, some other OEMs in here explaining what they're doing and going that. It's not a black box now that we don't want anybody to see except ourselves. And that's part of the free sharing we want to make happen in the examples we want to give. So I think it definitely is, it is moving in the right direction. Dave, I'm not sure if you got anything else to add.
Yeah, I guess it is worth talking about some of those kind of non-company specific committees and groups. I think they're actually quite critical. The convention is to kind of protect your own business and focus internally, but it's associations like those you mentioned that really do a good job of bringing us anti-social engineers to the table and working with competitors, other stakeholders to come up with what's best for the industry. I think it's critical to keep going with that fostering of intercompany discussion and problem solving for sure.
Right. I mean, just another point on that, Dave, on the collaboration, and a lot of credit to the disrupt mining that takes place at BDAC. But if you look at that, as far as engineering firms, I don't think in 10 years that engineering firms are going to be our competition, other engineering firms. It's the new technology, the data miners that are coming in. I mean, the competitors that we're seeing aren't going to be the ones we have today. So we need to work in collaboration to help get the industry going and work together as teams, whatever that is.
Yeah. Right on. I've got another question in here from Ben Sharp. Ben says, do you feel that the financial market investors will embrace the transformation changes that you have spoken of in general?
Dave, I'll start again. You can add on to that. And I think one of the things that we need to do with this when we talk about the innovation changes, a lot of the stuff we talked about isn't new to the world. Right. It's new to mining, right? So it's that messaging that the risk is minimized. It's a risk to this application, but it's not a risk to this technology. It's been used elsewhere before. Mm-hmm. And then the next thing, with all shareholders, they want to understand what's being on and make sure they're good corporate citizens. So environmentally, going back to our example, if you're showing here's some of the other benefits besides just financial, that will help this process get approved. So you actually can get return at the end of the day. There's another one. And I truly believe at the end of the day, it's like safety, and I get the same thing. Well, what about the extra cost of safety? And I think if you're working collaboratively, if you're thinking up front, if you're solving the problem, you can actually do it at a reduced cost, whether it's safety or innovation. These mines will be produced cheaper. They have to be. And that's what innovation is going to be doing. So the shareholders that have that in mind and support the right organizations, I think they'll be happy with it. I think there's more risk to organizations that don't accept the innovation or don't accept the change, that they're going to lose their shareholders.
Yeah, I tend to agree with you. Dave?
Yeah, and sometimes that's a matter of translating it into the right terms, using the right value drivers, if you will. Some shareholders may just want to know the monetized impact of all these different drivers. But as John said, it isn't necessarily that there's a technology risk. It's maybe disarming those perceived barriers by backed up evaluation, execution planning, all these things we can do to mitigate that overall risk. Because ultimately, shareholders are in it to make some kind of predictable return on an investment. That predictability is definitely impacted by risk profile. And as we outlined here today, there's certainly some of these strategies can be used to kind of ease off what that profile looks like, maybe give investors a little bit more confidence in the quoted rate of return and go from there.
Yeah, I think that makes a lot of sense, and I'm starting to see, and I think the average investor is getting smarter about what's going on in the world and learning more on their own about what's happening. And you know, I think it's going to get to a point where, and this is just my opinion, but where, you know, the investors are going to want to invest in the companies that are trying to do things differently and are trying to really reduce and make big step changes in their costs and step changes in their productivity. And I think pretty soon, you know, the investors are going to be looking for those companies, and those are the ones that they're going to want to invest in, the ones that are really pushing the envelope in terms of trying to do things better.
And even, I mean, that's a good point. Even like earnings per share, there's different market segments where that's not a driver. It's around growth or other things. And it's, you know, the whole financial market and the investors are understanding what the shareholder wants is important. And I don't think that innovation is definitely going to be seen as a detriment. It's around how well you embrace it, how well you actually plan for it, and how quickly you move to get it implemented.
Great point. Okay, do we have any other questions from the audience? I'll take them as I go. I've got a couple other things that I'd like to talk about too, so I'll jump in with a couple of mine while I'm waiting for some other questions. I really liked the thought about, and you know, I didn't look at it that way, which is, you know, interesting, but I love that you're using lean language and talking about lean manufacturing as it applies to mining overall. And you know, when you do look at, and I've certainly done a lot of work in that area in my past with Lean and Six Sigma in mining applications, but you know, you don't often look at it from a mine design perspective and say, you know, is this a lean setup? When you look at it, it really is not. You know, I mean, some of the, you know, everything's done for a reason. But when you look at it from a lean perspective, it doesn't make any sense. You know, and we move things around in mining so many different times, and we pick it up and we put it down, and we pick it up and we put it down. And you know, just from a lean perspective and a process perspective, there's got to be a better way.
Yeah, and I mean, it's a great point, and I lived through that with my own blinders on, like you were saying, you didn't even think about it. You know, we would look at an ore body and just take a, you know, mining stope, and we only counted dilution of what was actually outside that you weren't planning to take, you know.
Right.
So 97% of what you're taking is all waste, but to us that wasn't dilution of what was outside that square that came in, and okay, we got to stop that, which, you know, was small in proportion to the 97%.
Right.
So the next step was lean around, okay, well, how do we get that 97% to surface quicker or with less equipment,
right,
versus why are we even doing that with the 97%? And I mean, that's really what I've homed in on, and the group's done a great job in the industry, is saying, what is the value we bring to surface? And it's not tons, it's pounds of metal, and we need to get out of that concept of a tons per day or a tons per year. It's a pounds of metal or tons of metal if your grade's good enough to get those going.
That's a great point. Even the metrics that we measure ourselves by need to change at some point, right? Because, you know, tons per day may not be the right measure. How many tons of rock are we pulling out of the ground may not be what we want to measure ourselves on.
Ideally, it's ounces, right?
Yeah.
Good ore.
Yeah, that's great. You guys talked about a few and gave a couple examples of different scenarios, you know, that can kind of drive innovation. But I'm wondering, and all of those sort of started with some, I'll call it enabling technology that then opens up the door to a whole bunch of other things. What do you guys see as some of those enabling technologies that are really going to pave the way for doing things dramatically differently? You mentioned things like mechanical cutting and things like ore sorting at the face, but you know, what are some ideas that you've got on things that can enable?
Yeah, I mean, I think in the short term, and I was having a discussion with somebody today about how short that'll be, but I think, you know, electrification of underground, and we talk about electrification and people think about that as, you know, replacing the diesel engine with a battery or tied in electrics. And to me, I think when we think about electrification underground, we should be thinking about how we reduce the overall horsepower to a lower horsepower. Now, whether it's, you know, what's made up of diesel and electric horsepower now underground, conveyors, trucks, LHDs, miscellaneous equipment. If you took that total horsepower, how to reduce that down to a smaller factor is going to be a big driver. So battery equipment is definitely a big step. But I do think in the short term to midterm, underground haul trucks, LHDs, those will be getting replaced with more of a cutter. And now you've got a good particle size, an easier transport that's electric through, conveying or other type of mine carts that are out there. I think to me, those will be the same ones. Dave, and through the question before, talked about in situ, and maybe I'll just turn it over to Dave with a couple on that.
Yeah, I think it is about focusing on successes in other industries and finding ways to get them underground. That way you've got the implementation risk of technology limited to just application specific concerns. So mechanical cutting or liquefaction of some of the ore and waste together in a slurry. It is all about reducing those handling and rehandling activities. You're dumping something only to pick it up. You're dropping something by gravity only to have to lift it up again. And so yeah, mechanical cutting, hydro hoisting, for example, to make into a slurry your material and incrementally increase your production without having to commit to a new shaft, for example. It is definitely leveraging automation to refine the edges of those handoffs from one part of the process to the other. It's something that humans do fairly well, but we make mistakes and robots make fewer mistakes. I think automation is a well-known application that we can leverage in the short term quite a lot more than we're currently doing. And I'm definitely an advocate of that. It's just making sure people don't get lost focusing on those short-term gains and forget about the next step in that path to breakthrough.
I think the biggest enabler, Derek, is going to be the people in the companies. And, if you look back through the down cycle we had, were, very difficult in the mining industry, and I'll touch on a few mining companies, but I could probably give an example for all of them. But, Goldcorp brings out Disrupt Mining with major funding in a time where it's a huge down cycle. Or, BHP and Jansen and Heron Connect work on how we get shaft cutting and boring going on in large scale shafts. There's just so many of those examples where the industry, during difficult times where they usually chop off the R&D spending, committed to new programs or stayed committed to things that were already on the go. And I think that's going to be the biggest enabler, to tell you the truth.
Yeah. So I guess I'd be remiss if I didn't talk about people and the impact on people and the change management impact, since that's a big part of what we do. But how do you see the miners, the guys at the front lines, taking to all of this? Because this is a big change for them, and we've worked with a number of companies, even just on automating one little piece, and and making sure that guys understand what the benefit of that is, and it can be a hard sell sometimes. So looking at totally redesigning a mine and making it much more autonomous, how do you think? And how do you think you can deal with the impact to people?
So I think the industry has to, and it's not around removing jobs. It's actually looking at the workforce that's coming in and the number of people coming into mining. We're going to be in a crunch. If we want to actually get the resources out of the ground when we need to, we're going to be in a labor shortage to do that. So how do we bring in new labor? And I think this is going to be a great step in doing that. And I go back to a family day that I held when I was working in Sudbury before. And we had a small 1 1/4 yard scoop out with a remote package similar to what Dave's doing. And the kids that would come up there, I mean, I'm saying 12-year-old to 7-year-olds, and be able to drive that equipment just because of the games they play and the stuff they're seeing on TV. That technology, and even beyond that technology, is what the new workforce is going to know how to use and know how to do it better. It's going to be more difficult to find and train somebody on how to run a jackleg than it is to teach somebody how to autonomously or semi-autonomously run and control and manage a fleet of equipment from surface. It's just, that's the way the world and the technology within the world is going. Now, in different parts of the world, they're in different stages of that, obviously, but if we look at the modern mining, that is the way that it's going. So I don't think it's going to be an issue. It's the transitioning in this phase in the current mines or the current staffing where people are used to that. And, I'll give another example.
Yeah.
One more example, then I'll turn it over. But we purchased a jumbo, highly automated. You just have to put in the computer, USB, and it'll drill off the pattern for you. But 25 or 30-year experienced miners, they can drill better than that USB or the programming tells them they can, and it gets overridden and it doesn't get adapted or implemented. And so I think both the technology and the current workforce is going to be more adaptive to these changes, and we'll be able to implement them quicker and more effectively. Sorry, Dave.
Yeah, no, that's fine. Definitely touching on some good stuff. I mean, there's the new workforce that's people like my kids that can use electronics more seamlessly than I can now. But also, yeah, what do you do with the existing workforce? And I think there we have to have a commitment to getting everybody involved, getting the cynics involved, but also people who have very valid concerns and identified barriers that just need to address it. They need to have a place to express their concerns, a place to get involved. We're firm believers in active resistance if there's going to be resistance. There's no sense in trying to institute a change of that scale without addressing the culture. That culture is tied to communication and collaboration. And I think that's how you get that existing workforce on board. And once they're on board, they're part of the team. They're going to take some pride in developing some of these additional skills. And then, as we said, it's finding repurposed work fronts for those folks to apply their new skills and their call it old knowledge to something new, but also having more minds to deploy that workforce. So one operator can now control multiple machines, but an additional operator is maybe working on machines at a mine that wouldn't have existed if not for some of these alternative mine plans that we're looking for.
Yeah, and you may even be one guy controlling multiple machines in multiple mines potentially. I've heard talk of that. Now it's just because you're in one place doesn't mean you necessarily need to be working equipment all at the same mine. A lot of this remote technology now is allowing you to be much further removed from the ore body, doing a lot of the work, and I think that's a huge benefit that we can see down the road. Okay, well, if I don't have any more questions online, then I think we'll wrap it up. I'll give you one last chance to bring in some questions here as I'm wrapping up. But guys, I think this was a really great topic, great presentation. I really appreciate your time today. I appreciate you being able to join me in person here,
Yeah,
John.
no,
That was unexpected when we first started this conversation. I figured you guys would both be down in Arizona, so having you here in Sudbury is fantastic. Dave as well, great to do this with you. You guys gave a great presentation, and I really appreciated your time. Hopefully we can do it again sometime.
Thanks very much, Derek.
Thank you. Electronic high five for you.
Electronic high five. There we go. I like that.
Thanks a lot for your time and the opportunity. Hope the attendees learned something, or maybe hopefully we just triggered some new ideas, if anything. Thanks a lot for participating.
I think we did a lot of that. Just a reminder for everybody, what I'm going to do is I'm going to make sure that we get John and his team the list of attendees, and also get the attendees information on how they can connect with John and Dave.
Yeah, feel free to reach out for sure.
Yeah, and this webinar was recorded as well, so we will be sending out to everyone who was registered a link to the recording. We'll get you guys a link to that as well if you want to share it with anyone on your end.
Perfect.
All right.
Thanks again.
Thank you very much, folks. Thanks to all of you who attended, and have a great day.
Thank you. Take care. Bye.